A water tank has the shape of an inverted circular cone with base radius 2 meters and height 4 meters. If water is being pumped into the tank at a rate of 2 cubic meters per minute, find the rate at which the water level is rising when the water is 3 meters deep. Okay, so first thing we did is start off with our inverted circular cone. So inverted meaning it's upside down. And we're going to start labeling the things that we know right now. So I know from the center out, that radius is 2 meters. And I know that this is a right circular, so it has that perfect height given to us. And that height from here to the very tip they gave us is 4 meters. Now we're going to have to use some things later on to identify the fact that we don't know the radius at this given height. We're going to use that information a little bit later to try and figure out how to calculate this level of rising water. So we want the rate at which the water level is rising when the meter is 3, or when the water is 3 meters deep. Okay, so we have a little bit of information here. We also know that our formula, we always want to start off with a basic drawing and a formula. And the formula for this is 1/3 pi r squared h. And here's where our first challenge enters here is we can't have multiple variables easily unless we know multiple rates of change. Right now, we only know a certain amount of information. So we're going to try and eliminate one of these variables. I'm going to go ahead and try and get rid of the radius because I'm really worried about the rate at which the level is rising. So I'm really worried about the height. That's really what I'm focusing on in this problem, is trying to solve for the change of the height with respect to time. Okay, so let's start off with our formula then. So our volume, which is 1/3 pi r squared h. And I'm going to do a little bit of work on this off to the side so I can get a little information. If you look back at our picture here, I told you we had this ratio set up of this r compared to this r, and this height compared to this height, this little bit of height right here. So I'm going to try and set up a little ratio here. So I'm going to say that my radius compared to my height in that picture is the same as 2 meters compared to the 4 meters. So r over h would be the same as 1/2 when we reduce, or r would be the same as 1/2 h. And that's what we're going to use when we start plugging in onto this other side. So I'm going to go ahead and move this a little bit so I have some more space. V is equal to 1/3 pi. My radius now is this. So 1/2 h squared h. And I'm going to try and simplify this. So 1/3 pi. This is 1/4 h squared times h. Multiplying again to clean this up a little bit more. 1/3 and 1/4 multiplies to give me 1/12 pi. And h squared times h would give me h cubed. So here's what I'm really going to focus on now, is this formula here as we move into our next portion where I have to find the first derivative. All right, so we're going to put this down as our v equals 1/12 pi h cubed. And I'm going to go ahead and take the first derivative with respect to time on both sides of this. just like we always do to balance the equation. And we've already talked about this scenario a couple times. First derivative here would just give me dv dt. And on this side, we've got a couple things going on. The 1/12 is going to stay. Pi is going to stay because those are all multiplied. This one here is going to become 3h squared. And because those letters don't match, we're back to our dh dt, the implicit derivative. And now I'm going to go ahead and clean this up a little bit. And I'm going to get dv dt is equal to 3 times 1/12, which would be 1/4 pi h squared dh dt. All right, so we need to try and figure out what kind of information do we know here that we can start plugging in. So I'm going to start substituting in anything I know. So the first thing is, do I know any of this information? Well, let's go back. They told me that the water is being pumped into the tank at a rate of 2 cubic meters per minute. So based on these units, cubic meters and minutes, this would tell me that this is my dv dt. So I'm going to go ahead and put that in there. So that one I now know is 2 cubic meters per minute. I'm going to go ahead and put minute down here so we have time. 1/4 pi. Do we know our h? Well, again, if we go back, they told me that at this time the water was 3 meters deep. That's my h value. So I can go ahead and put in 3 meters squared. And I still have my dh dt. So now we have to do a little bit of math magic here and clean this up a little bit. So I've got 2 meters cubed per minute is equal to 1/4 pi, our 3 meters squared times dh dt. So first thing I'm going to do is what I like to do, which is fraction bust. I'm going to go ahead and multiply both sides by 4. That way I don't have to deal with fractions anymore. Nobody likes fractions, really. They're not difficult, but nobody likes to look at them. So we're just going to go ahead and simplify that up a little bit. And I'm going to get 4 times 2, which is 8 meters cubed per minute. 1/4 and the 4 reduce, so it's going to leave me pi. I'm going to go ahead and square this. So I've got 9 meters squared. And I still have my dh dt. Now, how do I get dh dt by itself? Well, here's where we're going to divide by the pi, 9 meters squared, on both sides. Pi, 9 meters squared. So over here, we can see the pi is going to reduce, the 9 is going to reduce, the meter squared is going to reduce. I now have my dh dt by itself. That's good. On this side, we're going to go ahead and try and reduce. So we're going to get 8, 9 pi. And now we have to check out those units a little bit here. So meters cubed, meters squared, that's going to leave me meters per minute. And again, meters is linear, and so is height. And time could be in minutes, which tells me that this does make a valid looking solution. So 8/9 pi meters per minute. So if we want to go back and look at our question here, it said find the rate at which the water level is rising. So we can now say the water level is rising at a rate of 8 over 9, 8 over 9 pi. Gotta make sure we put that pi on the bottom. And then this is meters per minute. There's our solution.